See, GIS, Geographic Information System, nowadays all of you are using actually in your day-to-day life. All of you are using Zomato services, you are using Ola and Uber services. They are based on GIS created maps only. In your, all of you are nowadays using your Android mobile and GPS is there. So, all of you are aware of or user of these geospatial techniques. Basically, GIS is part of your geospatial techniques, or other keywords for this is geoinformatics, and under this broad umbrella there are 4 main branches which are coming. First is your remote sensing, second is your GIS or Geographic Information System, third is your global navigation system or satellite navigation system. GPS is also the other name because first USA has developed this system. Then your photogrammetry. So, I think my previous speakers already have covered this basics of remote sensing, but a few things I am giving you again. As it is shown in the figure, remote sensing is acquisition of information from the object without being in physical contact. And here there are 2 modes of remote sensing, active and passive, and mostly it is passive. Only in case of radar and lidar it is in active mode. So, in case of passive mode, which is in case of passive remote sensing, the source of energy is sun. Basically, in remote sensing, what is the main thing which are required? It is electromagnetic wave or EMR. And we know that spectrum starts with cosmic rays, then gamma rays, then X rays, ultraviolet, visible, then microwave, in between thermal is there, and then finally radio wave. So, remote sensing is done in 3 different wavelength ranges. First is your visible, which ranges between 0.4 to 0.7 micrometer, means our eyes are also capable of seeing the things in that wavelength range. Then your thermal, and finally microwave remote sensing. In case of optical remote sensing or which is done in visible range, the purpose is to gather the information of chemical composition of the subject or the object under study. Means different in different wavelength ranges the purpose is different. If you have to know the information of earth object, means thermal properties of earth object, then we have to choose the wavelength range in thermal case like 3 to 5 and 8 to 14 micrometer range. If you have to gather the information of topography, means we have to go for microwave remote sensing, and in case of microwave remote sensing, back scattered energy is sensed by the sensor. In case of thermal, emitted energy is sensed by the sensor. In case of optical, it is reflected energy which is sensed by the sensor. In case of this diagram shows passive remote sensing, that too in optical range, because here it is sun is source of energy. The actual physical quantity which is sensed by the sensor is radiance. Radiance is what unit of radiance is watt per meter square per steradian. It is radiant flux leaving the surface per unit area per unit solid angle. This radiance is converted into, or it is quantized into digital number. Whenever I think all of you have seen sometimes satellite image, you have explored Google Earth, you have seen your hometown, where is your institute, where is your home, like that. So, those images are your satellite images, and when you open those images in any image processing software, if you click anywhere in the image, it will give you digital number. Pixel values is digital number, that is your quantized value of radiance. Actual physical quantity is radiance which is sensed by the sensor, and digital number which you are getting in the form of satellite image, it is digital number quantized value of radians, and that need to be converted into radians then reflectance if you have to go for further analysis. Because see, in case of remote sensing, it is that we have directly, we cannot rely totally on remote sensing. You have to go for field check at least for 10% of the area, and during this field check you have to carry that handheld spectroradiometer which gives you reflectance, and here in satellite image we are getting radiance. But nowadays if you, some of you have downloaded your LIS3 image from Landsat, from IRS series, from Bhuvan site, or Landsat 8 or Landsat 9 images from USGS. So it is available in reflectance form also, means L2 product. Okay, so that product can directly be compared with handheld spectroradiometer output which is in reflectance form. So next in the geospatial techniques is GIS, and today we will discuss in detail about GIS. Basically any geospatial project if you have to go for, so at least 3 things you have to use: remote sensing, GIS and GPS. Photogrammetry can sustain alone, but sometimes it is also needed. And see, in most of the projects we are using the product which is developed by photogrammetry, like a digital elevation model. Digital elevation model is one such product which is being used in every geospatial problem solving project. Okay, basically why we are using this geospatial techniques? Because we have to solve complex real world problem which are having spatial nature. Means there are some problem which are having a non-spatial nature, there are some problem which are having a spatial nature. Now the question comes, why to go for solving a problem? First of all, there must be some problem, there exists some problem. So when a problem can exist, when we can say yes there is a problem? If there is a gap between your existing state and expected state, जो आपके पास है, जो आप पाना चाहते हैं, उसके बीच में अगर गैप है तभी आप चाहते हैं कि प्रॉब्लम है एंड यू वांट टू सॉल्व. तो इफ द नेचर ऑफ सच प्रॉब्लम is spatial one means it is occupying some space in 3-dimensional environment and locational information is tagged with that, so that feature or phenomena is termed as spatial. Like reservoir is there, reservoir is occupying some space in 3-dimensional environment, but the property of reservoir means what is its perimeter, what is the water content, total water content, what are the sediments nearby that reservoir. Those attributes, those characteristics of that spatial data or that reservoir is termed as non-spatial data or attribute data. So why we are using geospatial techniques? To solve complex real world problem, and when the nature of problem is spatial one, GIS comes into the picture. And finally, see, suppose you are using you have to solve some problem. So you have to collect data from remote sensing technique, you have to collect data from GPS, sometimes photogrammetric technique, but final compilation is always done in GIS environment. So GIS in anyhow you have to use, okay, for any problem solving case. Next is your photogrammetry. See, in case of GIS, first GIS is everything is which are there in the real world as represented as a different layer here in case of GIS. We will discuss in detail what are those things and how we are representing this. So third domain is photogrammetry. Photogrammetry is taking measurement from the map. And see, photogrammetry is basically the art of taking measurement from the photograph, and here stereo vision is involved. Like in our human body, there is one remote sensing, that is remote sensor is there. There are 5 sense organs. Yes or no? So there are some sense organs for which EMR is used. Electromagnetic wave is prime requirement. Ear is also sense organ, but for ear we do not require EMR. Do we require? So what is the requirement for ear? Sound wave, okay. But in case of eyes, we require electromagnetic wave. So remote sensing technique is working or based on same principle in which our eye is working. Means in our human body, eye is one such remote sensor. Now we are having 2 eyes. With the help of these 2 eyes, we have got the vision of 3D vision. If we had only one eye, then we are not able to view in complete sense, in any object in complete sense, means 3D vision may not be possible, okay. So this photogrammetry is based on stereo vision technique. And in case of this digital photogrammetry, different stereo pairs of satellite images are being used to generate digital elevation model, and based on that measurement of height, measurement of buildings, those things can be done. And there are different softwares are available to perform this task. And GPS, the 4th domain under geospatial techniques. See, you must be knowing that nowadays, means since 2022, geospatial techniques has been introduced in GATE. Earlier this in GATE exam, this subject was not there. So being students of civil engineering, you are appearing for GATE, you can also go for GATE in geospatial techniques, and there are different dates also. Same day exam is not conducted, different dates are there, 2 dates are there. Now this GPS already you are using, it is there in your mobile, and you are sharing location. That sharing location is possible because GIS signals your mobile set is receiving those GPS signal. So minimum 3 satellites are required to get the locational information, and 4th is for time. So 4 satellites are being used at a time to get the exact location of any point. Now we are going in detail what is GIS. Basically in GIS different real world features are represented in different layers. And why those layers and what are those layers? What is spatial, what is non-spatial, we have already discussed. So basically in outside world we are seeing the features or phenomena which are existing. Some are having discrete boundaries and some are without any boundaries. To solve any real world problem, we have to generate real world scenario in digital environment. So in GIS also, whatever features or phenomena we are seeing in the world, those things we have to create in digital environment, then only we can solve the problem. So the few things which are having a discrete presence, like reservoir or mountain, they are having fixed boundary, discrete boundary. But our terrain, this undulations, everywhere terrain is there. We cannot say up to this terrain is there and after that nothing is there. Undulations are there, but it is continuous. Like air, everywhere air is there. temperature may vary, different concentration of these gases may vary, but there is not abrupt change. Yes, up to this air is there, after that there is no air, or temperature is of this room is 11 degree or 20 degree or 12 degree, after that it is minus something. This cannot be happen, means it is continuous representation. So because in real world there are two types of feature of phenomena which are existing. In GIS also we are two different data models we use. First is vector data model and second is raster data model. So vector data model is to represent discrete feature of phenomena and raster is to represent continuous feature of phenomena. All of you have all of you are taking images from your mobile on day to day basis. Today also many of you have, just now you have taken photographs. So what is the nature of that photograph? Those are raster or vector? Raster. Means whenever you zoom it, further zoom it, it will be, the output will be in pixelated form. Okay. So these photographs are in raster form, continuous form. So basically why GIS we use? It is of much concern that where something is happening, that is our concern to solve any problem. First of all, locational information is very much required. Now GIS is there, but it is not the conventional course like or conventional subject like your mathematics, physics, chemistry, like that. Many domains have contributed to bring GIS in its present form. So what are those domains? Those domains are geography, because it is geographic information system. It deals with the geographic data which are specifically geographically referenced. Geographically referenced means, see, whenever you are, all of you have seen that analog map, Survey of India topographic sheet. Some of you have seen SOI maps, Survey of India topographic sheet. Their latitude, longitude information is given. Whenever you convert that, that is analog form, okay? Paper form is always analog form. Whenever you convert that in digital form using what is the media, what is the means by which you can convert analog to digital? That is your scanner. Using a scanner, you can convert that analog map into digital form. So whenever you convert that analog into digital, the output is in raster form. It is an image, and whenever you open that image in any software and if you put cursor somewhere, it will give the information, location information, but it is in screen coordinates. But screen coordinates information, it is of no use for us. We have to, what is our requirement? Whenever I put the cursor, I should get the actual real world coordinate in spherical polar coordinates. Like in Google Earth Pro, you have explored your hometown. So in the, you put some cursor somewhere and in the lower right hand side you will get the locational information, that is latitude and longitude. So I think you must have remembered if you have to position a point, you have to show the position of a point. So it is generally represented as XY coordinate pair. In the same way, you are getting the locational information in Google Earth Pro whenever you are exploring. It is in XY coordinate pair. So X represents what? Is it latitude x? Anyone? XY coordinate pair, which all of you have seen in your while exploring Google Earth Pro, while exploring your hometown, your institute. So something you are getting in the lower right hand side as XY coordinate pair, real world coordinates. So x represents what? All of you agreeing x represents latitude? Or anyone is having some different opinion? Students, x represents latitude as per you. Yes, correct is x longitude and y latitude. Why? Because see, suppose x is your equator, okay, x axis is your equator and y axis is your prime meridian. So all the longitudes are parallel to prime meridian, which are varying along x axis, okay. So longitudes are varying along x axis and latitudes which are parallel to equator, those are varying along y axis. So that is why in xy coordinate pair, in real world coordinate system, x represents longitude and y represents latitude, okay. So first domain is your geography, because it deals with geographic information system, and geographic information system is dealing with data which are specifically geographically referenced, means whenever you click any cursor, put any cursor on the image, it should provide the real world coordinate system. If it is a spherical polar coordinate system, so longitude latitude in degrees. If it is map projection coordinate system, because sometimes we need to represent the map in any map projection coordinate system in which measurement unit is not degree, it is in meter. So why projection is required? To represent 3D Earth's 3D representation into plane, then any projection is required, no? So if you use any map projection coordinate system, the measurement unit is always meter. So in that case, either polyconic or UTM, the measurement unit is meter, and you will get the latitude longitude equivalent in UTM and polyconic projection. The second is your the second subject which has contributed to bring GIS in present form is cartography, because one of the this output of GIS is map, okay, and cartography is art of map making. So cartographic techniques like this main thing is color combinations which are being used in cartography, the same is followed in GIS also. Like in cartographic map, we represent river as which color, by which color? The same convention is followed in GIS also. We cannot represent river as red color, in red color. Contours are represented in cartography by which color? Contours, brown. The same here in GIS also. Buildings, red color, the same in GIS also, okay. So cartographic conventions are being followed in GIS based maps also. So cartography is another domain which is contributing in GIS. Next is because geographic information system means it is digital, it is everything is done in digital environment, means it is computer based system. So computer science is definitely coming into the picture. Next is mathematics, okay. So how mathematics is coming into the picture? Because we have to solve complex spatial problem. So how we are solving those problems? Because we have to use different models. What are those models in GIS environment? those are mathematical formulation of physical laws which are coded in computer languages. So mathematics is also contributing in GIS. Okay. So these are the four subjects: cartography, geography, then computer science and mathematics, which have contributed to bring GIS in present form. Vector and raster representation, why it is needed? So there are two types of data model which are being used in GIS, vector and raster, because there are two types of feature of phenomena in real world. And if you have to solve any real world problem, you have to generate real world scenario in digital environment, and you have to represent real world feature of phenomena in digital environment. Okay. So suppose this the upper portion is of the figure is real world. So how it is represented in raster and how it is represented in vector? So in raster it is rectangular array of cell, and each cell is termed as pixel or picture element in 2 dimension. Whereas in case of vector representation, it is composed of point line and polygons. So basic spatial unit, in case of like we have studied that your any matter is composed of atoms. Atoms are composed of electron, proton, neutrons, and few years back it was known that those fundamental particles cannot further subdivided, but nowadays we know those are also further subdivided, and then quark particles are there. Those are the fundamental particles now. Okay. So in case of raster and vector representation, the basic spatial unit in case of raster is pixel. We cannot break pixel further. Okay. We have to start with pixel only. Like in case of vector, we have to start with point only. Okay. So point is basic spatial unit in case of vector, and pixel is basic spatial unit in case of raster. See, I am giving overview of basics of GIS, then we will go in detail how GIS is being used for solving any real world problem. Okay. So first basic overview. This is again an example of vector and raster representation. See, vector is represented or it is stored because we have to store also in the system. In case of vector, suppose we have to store a line, straight line. So only 2 coordinate pairs will be required to store, and computer storage is done in the form of ASCII codes. Okay. So suppose one straight line is there. It is big road, but road is straight line only. There is no curve in between. So only start point and end point we have to store, and again in the form of coordinate pairs. So all the calculations in case of vector is based on coordinate geometry rules, whereas all the calculations in case of raster is done using matrix algebra rule, because raster is stored in the form of matrix as an array. In case of vector, it is stored as coordinate pairs. If it is a single point, so one coordinate pair is stored. If it is a line, straight line, 2 coordinate pair. And whenever we have to give the shape to a line, we have to introduce some vertices. Vertices are in context of GIS, sometimes vertices are also termed as pseudo nodes. Later we will discuss why it is termed as pseudo nodes, and it is considered as error also. So basically in case of vector and raster representation of the same road segment, which is very big on the ground but it is straight, so in which case you assess that more storage space will be required? Vector and raster. Because in case of raster, many pixels will be required to store. If you have to store a pixel, means its origin and dimension of pixel. Three things you have to store: xy coordinate pair, then dimension. In case of vector, only xy coordinate pair. So in case of raster representation of the same road, many pixels will be required. You have to store many pixel information, but in the same way, if you have to store the same road segment, only two xy pair will be required to store. Means raster representation occupy more space in the system, and vector representation occupy less space in the system. This already we have discussed. Now the exact definition, technical definition. Basically, GIS is a computer based system which is being used to solve real world problem when nature of problem is spatial. The exact bookish definition is given by Peter A. Burrow, who is also author of first GIS book, Principles of Geographic Information System. As per Peter A. Burrow, GIS is a powerful set of tools for storing and retrieving at will, transforming and displaying spatial data from the real world for a particular set of purposes. So everything which are considered as functionality of any GIS software is given in this definition only. So basically it stores the data. Any GIS system stores the data, geographical data, either it is spatial or non-spatial. It is capable of performing any analysis on that, then giving the output in different dimensions. Like we can visualize the output in 2 dimension, 2.5 dimension, 3 dimension, 4 dimension, like that. Different dimensions are possible to visualize. Now different components of GIS are there. First is your computer hardware, then software, people and data. So because it is a computer based system, so computer basic setup of computer is required, but some additional hardware is also required, because you have to input the data in GIS environment. You have analog maps, so you have to first get converted into digital form. So for that, what is the device which is being used? Scanner. So scanner is must input device in case of GIS system. Then output you visualize on the monitor, but you have to show the result of your analysis to the administrator. तो कैसे दिखाएंगे administrator को? तो you have to take print out, A0 print out. Okay. तो color plotter is also must output device in case of GIS system. So these are hardwares. GIS software, I think some of you have used GIS software. The commercial software or licensed software is ARSGIS, and open source is Quantum GIS. These two are very much popular. And who are the user? There are two types of user. One is general user and another is analyst. General user cannot handle each and every tools and menu of GIS software, but like administrator, he only needs some tools and buttons to get the answer of their query. But after being a student or of geospatial domain, after doing some course in geospatial domain, the students is considered as geospatial analyst. So there are two classification of people which are using GIS. One is general user, another is analyst. And data, what type of data? Geospatial data means spatial and non-spatial, both type of data are being used. Spatial data which are of two type of nature, vector and raster. Vector is discrete representation, raster is continuous representation. Raster all of you have used. you are using on regular basis because you are taking photograph, those photographs are raster. These are the hardware, software, people and data. So what are the sources of data? In GIS environment, you have to input certain data. So from where you are getting those data? So first source is remote sensing technique. Satellite data is big source of data to be input in GIS environment. Suppose you are doing network analysis. Okay, so road network is required. You are having topographic sheet. From that you can extract road network, but topographic sheet is having survey done long back, means early 60s, and nowadays so many changes have taken place in road infrastructure. So from where you update, you can update the road network which you have extracted from topographic sheet, latest satellite data. Okay, and what is the source for satellite data? You can download from Bhuvan, our own Geoportal. You can download from nowadays high resolution satellite images are available by ESA, European Space Agency, Sentinel-2, 10-meter resolution. For visualization you can use Bhuvan also, Cartosat series of data, all can be visualized, but for download purpose LIS4 is there. LIS4 you can download from Bhuvan. Now you are directly download vector data also from Bhunidhi. So nowadays Indian government has made public many data set and you can download free of cost. Only thing is you have to log in, you have to create your login and you can download many data sets free of cost. So data is no problem, but you have to bring all the data sets in same environment. Same projection parameters would be there if you have to use any data set. These are the different applications, different problems where GIS can be used. How different point, line, polygons and volumes are represented in GIS environment. See, in GIS there are two concepts, feature and layer. So suppose one point layer we are representing post office locations. Okay, so entire post offices of Jharkhand if we are representing, that is one layer, but the post office which is located in Sindri, BIT Sindri, that is one feature. So there are certain operations which are feature based as well as layer based. So based on the requirement we can go for certain operations which are feature based and layer based. What is vector representation? What is raster representation? In vector always XY coordinate pairs are being used. All the calculations are based on coordinate geometry rules, whereas in case of raster matrix algebra rules are being followed because it is stored in matrix form as an array in the form of rows and columns. These are the basic difference between raster and vector. Raster, the first difference, whenever anyone asks what is the difference between raster and vector, raster is for continuous representation like terrain, your air. Okay, you have to suppose air quality index you have to display, so or you have to represent, so it is represented in the form of surface in raster form, but vector representation is always discrete one. Like you have already all of you have or most of you have seen that tallest building of the world. What is the tallest building? So you must have explored in this Google Earth Pro. What is the in 3D you have must have you can measure the height also there. So those are 3D objects, those are vector representation. Now the popular GIS software is ArcInfo, and ArcInfo nowadays it has come to ArcGIS Pro. So in ArcInfo there is one slash between Arc and Info, whereas in ArcGIS there is no slash. तो क्या ये स्लैश जो है ऐसे ही गलती से दे दी गई है क्या, बाय मिस्टेक स्लैश दे दिया गया वहां, या इट कैरीज सम मीनिंग? सी ArcInfo, it is the first commercial GIS software developed by ISRI, Environmental System Research Institute. That time Arc segment, there was two segment in that software. Arc was being used to deal with spatial features and Info non-spatial features or data part. Okay, and those two segments or those two modules were tightly coupled to each other. But nowadays, means those are stored in separate locations. Spatial part are used to be stored separately and non-spatial part used to be stored separately. But nowadays in ArcGIS there is no slash, means everything is stored at a same place in geodatabase. Now geodatabase concept is coming to the picture, has come into the picture in case of ArcGIS, and ArcGIS Pro is advanced of that ArcGIS. Okay. So earlier that architecture of ArcInfo was geo-relational, but architecture of ArcGIS Pro or ArcGIS is object relational. See, this GIS, it deals with huge amount of data set, and any DBMS is also dealing with huge amount of data set. So GIS can be considered as DBMS because both are dealing with large amount of data set. One of the output of GIS is map, one of the output of cartography is also map. So GIS can be treated as cartography. So GIS is neither DBMS, GIS is neither cartography. Okay, it is much more than that because it has the capability to solve complex real world problem. It has the capability for performing analysis which are not possible in case of DBMS, in case of cartography. But because it has to handle large amount of data set, DBMS is required. So which kind of DBMS is required in case of GIS? In case of ArcGIS, this in the back end always relational database memory system is running, and that too MS Access. In case of ArcGIS it is MS Access. So every GIS is supported by DBMS to handle large amount of data set. Without that it is not possible to handle large amount of data set. Particularly geodatabase, which is a container of ArcGIS, it can store spatial, non-spatial, everything at a same place. That is why there is no slash. Okay, everything are stored in tabular form, spatial as well as non-spatial. And relational database maximum features are being taken from relational database management system and few from object oriented DBMS also. That is why the architecture is object relational, whereas in case of ArcInfo the architecture was geo-relational. Relational data set, relational DBMS was there in case of ArcInfo also, but in ArcGIS it is relational as well as object oriented. Both the concepts have been taken in ArcGIS, particularly in geodatabase. So these are the different modules which are available with ArcGIS. Nowadays whenever you purchase institute license, it is coming under ArcGIS Enterprise. It can contain ArcGIS Desktop, ArcGIS Online, Developers, Apps, and under ArcGIS Desktop you are having several modules. To develop any spatial database, 3 modules are always required, which are Arc Catalog to create data and to manage data. Then ArcMap to visualize, to provide input, to visualize the output. Then Arc Toolbox, it is a basically it is a container of all the functions, all the models which are mathematical formulation of physical laws coded in computer language. Okay, so Arc Toolbox. So these three are must to be used, and ArcScene and ArcGlobes are for visualization in different dimensions. Okay. These are how to start in ArcGIS, but these are the points which are very much important for you. Suppose you are planning to use GIS for your project. Okay. So these steps you have to follow. First of all, you have to input your data in GIS environment. After inputting the data, what are the tasks you need to follow? First is your geofencing. Geofencing is the process by which you provide real world coordinate to your spatial data. The first thing we do in GIS environment is to project or geofence your data in real world coordinate system, from screen coordinate to real world coordinate system. Some transformation, polynomial transformations are involved. You have to provide coordinate system information, you have to provide spheroid information, datum information, you have to provide ground control points. Ground control points are those points for which you already know the real world coordinates. Okay, so those things being used for geofencing purpose. Next thing is you have to create a spatial database, means the database which are replica of real world feature or phenomena, using by two different data models, vector data model and raster data model. After creating a spatial database, you have to perform topology creation. Topology creation is very much required in case of vector data. See, in real world there are different type of spatial relationships which are existing. Okay, so like your Jharkhand is part of India, India is part of Asia. It is actually truth for the real world. So you suppose you have to store this truth with your data, so you have to create topology. This property of spatial relationship is termed as containment, means Jharkhand is contained by India, India is contained by Asia. So this is actually the truth of real world, and it has to be stored in the database so that you can perform any kind of analysis. This is termed as containment and polygon arc topology. Likewise, in India, Delhi and Kolkata is connected by different, by road network, by air network, by rail network. It is the truth by different city locations. In between different, if it is road and rail, different city locations are there. If it is by air, so some points may be there or there is direct flight. Okay. So these are termed as, because these are connected, different cities of India are connected, so this connection is already there in the real world. You have to store these connections in the database, and that is possible due to topology creation, and this property of topology is termed as connectivity. Next is your in Jharkhand, suppose this is this BITS Indra is coming under Dhanbad. What is the neighboring district of Dhanbad? Bokaro, Giridih. So these are actually existing in the, actually it is the truth of real world, and this truth we have to store in the database, and it is possible with the form of topology creation, and this property of topology is termed as this contiguity and also adjacency. See, again in geospatial domain, three terms are being used. One is discrete, another is continuous, and third is contiguous. Discrete is something which is having fixed boundary. Continuous means without any boundary, and contiguous means it is continuous representation but with boundary. Like administrative boundary, without any gap these boundaries are there, no? Means if you will go for this district map of Jharkhand, so different districts are adjacent to each other, there is no gap in between. So this is termed as contiguity. So to solve any problem, you have to store these spatial relationships also with your data set, and this is provided by topology. So if you have created database, vector database, so you have to create topology to store those spatial relationships also with the database. Okay. So after that, whatever analysis you will do, it will be correct. So topology creation is must for your vector analysis to get the correct output. See, contiguity is again contiguous term is again very much critical in case of remote sensing also. So see, remote sensing is done different wavelength ranges. Okay, different bands are there, and those bands means we can visualize only 0.4 to 0.7 micrometer, but sometimes it is required to visualize beyond that. Like सभी ने सुना होगा कैसे जो इराक में उनके जो प्रेसिडेंट थे कैसे उनको यूएसए ने डिटेक्ट किया और कैसे फिर एंड हुआ, तो उसमें थर्मल रिमोट सेंसिंग वाज बीइंग यूज्ड. तो थर्मल को हम लोग आंखों से विजुलाइज नहीं कर सकते, but in remote sensing it is possible to capture those information also which is not possible for us to visualize with naked eye. Okay, so thermal different bands are possible, means sometimes it is required to get information in different wavelength ranges without visible boundary. Okay, so in case of hyperspectral remote sensing, there is one important term in hyperspectral remote sensing, so in which bands are contiguous, means they are having some upper bound and lower bound of the band, but those bands are contiguous. Like suppose Landsat, LIS3, these are multispectral sensor, but Hyperion, this is hyperspectral sensor. So what is the difference? Why this hyperspectral sensor is termed as contiguous in nature? Because suppose here in case of LIS3 and this Landsat or Sentinel, bands are discrete, means suppose one band is 0.5 to 0.52 or 500 to 520 nanometer. Another may start from 590 to 590 or 610 nanometer. But in case of hyperspectral, every band is having same bandwidth, almost same bandwidth, and that is spectral resolution is very high also. So if it is starting with 520 to 540, the next will start 540 to 560, like that. There is no gap in between. All bands are contiguous to each other, and that is required in case of your species identification. Like in multispectral, it is possible to classify the broad land use land cover classes, but what is vegetation, what is settlement. But suppose in case of vegetation, you want to know in detail whether it is crop or forest. In forest, what is the forest species? So those things if you want to go, you have to use hyperspectral remote sensing, okay, because in hyperspectral remote sensing there is no gap in spectral response. In remote sensing, I think spectral response must have been discussed by the previous speakers. In remote sensing this spectral response is very much critical. Based on spectral response only everything is analyzed. It is a curve between wavelength and reflectance, okay. So in case of hyperspectral, this spectral response is continuous, there is no break in between, but in case of multispectral there is a break. So again that is coming under domain of hyperspectral, we will discuss later on sometimes. So today we are going to discuss GIS, so more in detail we should concentrate on this. So after topology creation you have to link your spatial and non-spatial. Why it is required? See, you have created your database, and because in the back end your DBMS is running, so automatically you are getting table also for your spatial data. No need to create separate tables for your spatial data, because DBMS is supporting the GIS, so automatically it is creating for your spatial data whenever you are creating any spatial data. But suppose your requirement is you have to find out some socio-economic analysis you have to do, like being a geospatial analyst, you have to tell the government that government is in need that literacy is very low and in particular pockets, and we have to provide the educational facility. To improve the literacy, which educational facility you have to provide? College or school? इंजीनियरिंग कॉलेज से स्टार्ट करते हैं लिटरेसी के लिए, तो किस लेवल का स्कूल? प्राइमरी स्कूल. So suppose we have to find out which are the villages where there is less number of primary school and SC/ST population is more. So this complex query is required to get the visual representation. See, in DBMS also these queries are possible, but visually where are those clusters, village clusters where there is immediate requirement? If it is represented in map form, so it is easier for the administrator to take any decision. So that is why, see, in the table you can perform query, because GIS is supported by relational database management system, and there are three major property of relational database management system which are being used in GIS. First is storage in tabular form, second is capability of relate different tables, and third is capability of performing SQL queries. So these properties are also being used in GIS. So using that properties means different tables you can join, like socio-economic data. What is the source of socio-economic data? Demographic data. From where you can get? Census is the source, na? Census of India site you can download the demographic data. Suppose for any district, for village boundary already you have created, so you can link those census data with your village boundary map, and then you can perform complex queries. So storage in tabular form, capability of linkage between spatial and non-spatial, then performing queries, those three are also possible in GIS, because GIS is supported by relational database management system. Okay. So after doing that, you can perform different raster and vector analysis tools on the data set which you have created, and finally you have to compile the map. Suppose you have you have extracted any vector from the map, so that is only drawing. कोई भी ड्राइंग को मैप कब बोलेंगे? जब उसमें सारे मैप एलिमेंट्स होंगे. मैप एलिमेंट्स मीन्स नॉर्थ एरो, स्केल, लीजेंड, टाइटल, okay, and grid and graticules. Okay, so if those are present, then only it is termed as map, otherwise it is mere drawing. So the last step is map compilation. So if anyone of you or anyone wants to use GIS for any project purpose or for any problem solving, so you have to follow these steps. So these are the topology property. See, whenever you are creating any, extracting any vector out of raster, so some tables are created. But after topology creation, few additional fields are included in the attribute table. In case of connectivity, the tools or fields which are added are from node and to node. Okay. Vector generally in terms in context of physics, it is associated with vector. किसे बोलते हैं? Dimension and direction. जब दोनों होता भी वेक्टर होता है ना, तो डायरेक्शन को कैसे स्टोर करते हैं इन GIS? डायरेक्शन इज स्टोर्ड बाय फ्रॉम नोड एंड टू नोड. जब भी डिजिटाइजेशन हम स्टार्ट करते हैं, किसी पॉइंट से स्टार्ट करते हैं ना, स्टार्ट पॉइंट, फिर हम किसी डायरेक्शन में मूव करते हैं, दैट इज इन पॉइंट, फिर वहां से पॉज लेके फिर हम दूसरे तरफ जाते हैं. तो यूजिंग दिस फ्रॉम नोड एंड टू नोड, direction is stored in the database. So whenever your network analysis you have to perform, so using these fields the system decides what is the direction. See, in network analysis there are various traffic rules also which we need to store. See, one more thing which I want to highlight here. Earlier ARC-info was the commercial GIS software and coverage was the file format being used. Coverage with coverage we used to create topology, and nowadays geodatabase, under geodatabase feature data set is the vector file format with which we can create topology. But topology creation of coverage and topology creation of feature data set of geodatabase, both are different. Some difference is there. Both are topological vector file format of ArcGIS, native vector file format of ArcGIS, but topology creation has some difference. So ARC-info was very old software. That time may have flyovers were not that much in the real world. तो नेटवर्क एनालिसिस में सपोज इमरजेंसी सिचुएशन के लिए हमें नेटवर्क एनालिसिस करना है, एम्बुलेंस को हमें डायरेक्ट करना है फ्रॉम वेयर टू वेयर इट शुड गो, व्हाट इज द शॉर्टेस्ट पाथ, ओके, व्हाट इज द क्विकेस्ट पाथ, दोज थिंग्स वी हैव टू फाइंड आउट. एंड our data we have created database with coverage. Topology creation has been done. तो कवरेज में क्या होता था, जब भी दो लाइन इंटरसेक्ट करती थी तो एट द पॉइंट ऑफ इंटरसेक्शन वन नोड इज क्रिएटेड. तो अब फ्लाईओवर का केस है, आपने डिजिटाइज कर लिया, एक्चुअल में फ्लाईओवर ऐसा है, इंटरसेक्शन नहीं हो रहा ना, नोड नहीं होना चाहिए, बट जब आपने कवरेज से किया टोपोलॉजी क्रिएशन तो वहां पे नोड क्रिएट हो गया, मीन्स दैट इज ऑल्सो टेकिंग पार्ट एज इन नोड. इन नेटवर्क एनालिसिस में शॉर्टेस्ट पाथ में वो भी एक नोड हो गया, तो एक्चुअल रिजल्ट तो रॉन्ग आएगा ना. तो इन केस ऑफ जियो डाटाबेस नाउ वी कैन प्रोवाइड द रूल्स, टोपोलॉजिकल रूल्स. यस, फॉर दिस पर्टिकुलर रोड सेगमेंट वी डू नॉट रिक्वायर पॉइंट ऑफ इंटरसेक्शन इन नोड एट द पॉइंट ऑफ इंटरसेक्शन. जो फ्लाईओवर है वो फ्लाईओवर की तरह ही वर्क करेगा. तो दैट इज व्हाई जियो डाटाबेस नाउअडेज हैज कंप्लीटली रिप्लेस्ड कवरेज. Now coverage is coverage file format, which was native file format of ArcGIS. Nowadays it is not in use. This is connectivity. From node to node are the fields which are added automatically by the system. Then this is area definition. It is also termed as containment or polygon arc topology. And polygon list and arc list, these two are added. Next is contiguity. Left polygon, right polygons are added after topology creation. So after topology creation, certain fields are automatically added by the system in the attribute table to store those spatial relationships. These are the vector file formats. The native vector file formats of ARSGIS are shapefile, coverage and feature data set of geodatabase. Under these three, coverage and feature data set of geodatabase, these are topological file format, whereas shapefile is non-topological file format, but it can retain topological information when converted from coverage or feature data set of geodatabase. You can digitize your files in AutoCAD also, and those can be imported in ArcGIS environment. Now we can go for geoprocessing. What are the vector and raster based techniques which can be used in GIS environment? See, the spatial analysis in its complete form, it is the process, three-step process. First is data collection, means problem identification. Based on that problem, you have to identify the parameters by which you can see. In real world, every problem is multi-criteria problem. You cannot solve the problem by mere considering one single criteria. You have to take into the consideration many criteria into consideration at a same time. Okay. So complete spatial analysis is three-step process. Problem identification, data collection is first step. Then second step, you have to apply models based on the purpose, vector based or raster based. And third is data visualization in different dimensions. This is the complete set, but geoprocessing is only deals with the second step. Under geoprocessing, input data you have to provide, you have to use geoprocessing tools, and the finally new data set is generated. Like this is one old Ranchi district, and Ormaji is one clip layer. Okay, and we have to find out what are the villages which are coming under Ormaji block. So Ranchi input layer is your Ranchi, clip layer is your Ormaji, and after performing clip, we are getting village boundary map, that is the last one, Ormaji village boundary map. So this is the way in which geoprocessing tools are working. Now similar way, there are different techniques for raster analysis. In raster, basic classification is local, focal, global, regional. Under local, your reclassification, then overlay. Reclassification is single layer, whereas overlay is multi-layer. So different techniques which are coming under this raster also. Like this is overlay, it is multi-layer, and here it is under overlay, because it is local operation, means local operation depends on the number of pixels taking part in individual operation. Here output at a particular pixel location is function of input at that pixel location only. Like precipitation layer is there, and losses means evaporation and infiltration is there. So what is the final runoff? So you can subtract losses from precipitation to get the runoff, surface runoff. So this is output at pixel location 7, where precipitation is 7 mm. we have subtracted 7 minus 2, where 2 is your losses, to get the final run of 5. So here at a particular pixel location, that particular input at that pixel location only is taking part. Okay, neighboring pixels are not taking part in the operation. This is termed as local operation. T.
Ma'am, if you are comfortable, then we can go for tea break.
Okay.
We'll continue.
Okay, we can go for tea break. Okay, after tea break, I will discuss the application areas. There are so many things in geoprocessing tools also, but I will start from geospatial applications. Okay, the actual applications, the projects we have which I have completed, those things